thesis of Cosmos, the interchain of blockchains, was like really verified. We have saying all this. We have all these hundred of blockchains, and
Yeah.
they are trying to communicate to each other. At the beginning, Bitcoin and Ethereum, they used to think of we are going to create everything on like this blockchain, and there is not that need to talk to each other. That thesis Cosmos came and was like, yeah, no, these blockchains, huge blockchains, are not going to be just an island.
What's up, everyone? Welcome to Proof of Talk. I'm your host, Andre, and I'm here today with Maria Gomez and Susanna Evans, who are the managing director of Interchain and the product lead for the IBC protocol. Thanks a lot, guys, for accepting my invitation. How are you both doing today?
Very well, thank you. Thanks to you, Andre, for inviting us.
Oh, no, it's my pleasure, honestly. I think that you have an amazing series of tools that you are currently developing, that you have developed in time to really support with inter blockchain connectivity. And I think there's going to be a fascinating discussion. So maybe you want to start by giving a high level overview of the vision of Interchain and what are some of the key areas that you guys are working on right now and looking forward towards 2024?
Yeah, I can go ahead, and
Anyone can
Susanna, you
take it.
can.
It's out there. Anyone's free to take it.
Yeah. I'm going to take it from a very high level, and maybe Susanna can complement, and especially from the IBC perspective. So the thesis with the interchain, or the thesis, the Cosmos thesis, is that there is going to be this world which is full of blockchains, um, and is for the communities to define what is it that they want to focus on. And so the idea with the tools that we are trying to develop is that people are it's easier for people to set up a blockchain and
Mm-hmm.
adapt that blockchain to their local needs. That's the main high level thesis of the interchain. And so part of the interchain stack is the IBC,
Yeah.
which is the communication protocol between the different blockchains, the SDK,
Mm-hmm.
which is that set of tools with different modules that people can go and pick in order to launch their chain. And then we have the consensus engine, which is Comet BFT. Those are the
Right.
key things that developers need to set up and launch their own chain. And so that on a high level is the thesis, is the Cosmos thesis, or the interchain thesis. And those
Mm-hmm.
blockchains are not isolated islands. They talk to each other, and that's why the IBC protocol is so key.
Right. Yeah. So you basically have the Cosmos SDK, which contains the set of tools to build blockchain specific applications that are compatible across any other blockchain who also uses the tools that from the Cosmos SDK. You have the Cosmos hubs, right? The ecosystem of interconnected apps and services that grows with every other addition to that base chain. Then there's the IBC protocol, which we're going to go in a bit more detail. And then what I thought it was really interesting that you have Comet BFT that you just mentioned, which is the Byzantine fault tolerance system, which effectively for anyone that doesn't know, it's an algorithm that's actually inspired by back in the days of like the Byzantine armies, right, when they were ensuring that the army can continue to march or operate even if not all of the members of the army are still there, or some of them, I don't know, deserted or something like that. So your guys, basically it means one third of the chain, so long as two thirds of the chain are remain intact, the network will continue to have a consensus layer, consensus mechanism that works without being interrupted. Susanna, if you want to go into a little bit about the IBC protocol and talk about how all that works, I think that would be super interesting.
Yeah. So kind of as Maria mentioned, you've got loads of different blockchains in the interchain, we call it. I think right now there's over 100.
Mm-hmm.
And, kind of as Maria mentioned, each chain has the ability to choose like what it wants to specialize in, what application it actually wants to have. And then the idea is that chains should be able to leverage other applications from other chains and kind of seamlessly send messages, data, tokens between them. And in a kind of truly sovereign world, then we don't want to have to rely on someone else, another blockchain, some kind of intermediary to enable these chains to communicate. So this is kind of why there was a need for this interoperability protocol, which would allow blockchains to communicate on a peer-to-peer basis. So not adding in any kind of intermediary that verifies something happens on one chain and then lets you do it on the other. Instead, we use something called light clients, which is able to track the state of another chain. And then you just have to update the light client to verify that something happened on one chain, and then you can perform an action on another chain. So the
Right.
inter-blockchain communication protocol is a generalized protocol which enables this communication between chains and doesn't add in any additional trust assumptions. So you just have to trust the blockchains that you want to send messages to each other. And this is kind of a really core part of the protocol. And the protocol is used really extensively in Cosmos, but it's actually a generic protocol that can be extended to other blockchain ecosystems as well. So not just the chains that use Comet, Cosmos SDK, maybe they have
Right.
Cosmos and stuff. It's actually a general protocol.
Right. It's also the most popular, right, interchain protocol on Cosmos, isn't it? It's definitely one of the biggest, if not the biggest one, like the most popular one being used.
Yeah, I think because, well, it's if you're building with the Cosmos SDK and Comet, it's just another module which you enable. So it's like you've got this really powerful protocol to communicate with other chains. It just makes a lot of sense that you would want to then enable that on your chain. And I mean, the network effect just grows. Like as more and more chains kind of join the network, it just becomes increasingly desirable for you to want to also be a part of that network.
Right. Yeah, that makes perfect sense.
Yeah.
Just going back to the idea of light clients and the fact that you don't need a third party to run this thing. So it's basically you're making bridges. Bridges are known to be relatively unsecure, right? A lot can happen. They can be vulnerable to attacks. Whereas the light clients are not like bridges at all, from my understanding. And please correct me if I'm wrong, but from my understanding, the light clients are like a very light copy of blockchain A on blockchain B, and therefore they're kind of aware, each chain is kind of aware of the other chain's state, and that's how they're able to transact securely without needing a bridge.
Yeah. So I think maybe so bridges definitely is kind of
If I butchered that, let me know.
no,
Like,
no, that's actually really, like a great way of explaining it. But I'd say, yeah, when people think of bridges, it's definitely like a loaded term. And I think people think of bridging as kind of these externally verified bridges. So where you do have some maybe like chain in the middle, or you've got some kind of Oracle off-chain service, which is like saying this thing happened on the other chain, rather than using light clients. But then
right.
I think bridging is just like one of the use cases of interoperability, because bridging um, is just moving tokens between chains.
Yeah.
So IVC, it's not a bridge in the sense of these kind of externally verified bridges, but it does enable you to move tokens between chains. So it enables the bridging use case, but it's not like a bridge that we think of. A bridge is kind of, the bridge hacks and this kind of
Right.
thing. And yeah, exactly as you said, like a light client is just um, a a way to track the state of another blockchain, and it's more lightweight than running a full node, because with a light
Right.
client you don't have to track every single block that the blockchain is producing. You just need to update the light client with the blocks that you're kind of interested in. So it's like
Right.
there might not be an IBC transaction on every single block. So it's like you don't have to therefore then like follow every single block as you do with a full node. So a light client is a lot lighter, and this is kind of important if you've got it on chain, like kind of state is a kind of more scarce resource. You don't want to just like grow the chain, inevitably if you're running a full node of every single chain that you want to connect to, it's going to be a lot. So yeah, light clients are just a more succinct way of tracking a counterparty that you want to communicate with.
Right. And I think that's a very important distinction to mention, that a light client is not a full node, but instead it connects to a full node, right? It gets the data that it needs from a full node and then goes like, okay, this is what we have on this chain. This is how you need to reconcile this data. So you've also
Yeah.
mentioned that it offers the obviously the bridging capability, but without the vulnerabilities of an actual bridge that you manually build between these chains. What are the use cases are there for the IBC protocol?
So you could send arbitrary data between two chains. You can create a chain on another account and control it from another chain. So we call it
Hmm.
interchain accounts. You could query the state of another chain, kind of an interchain query. We also have so we have like application modules, and you can build your own application module, but we also have middleware, which means that you can extend existing application modules. So we see some really cool use cases of people will like use a token transfer, but then they're also using a middleware to then do something with those tokens and maybe send them on to another chain. So for instance, you might send your tokens to Osmosis, then perform a swap, and then
Hmm.
send that back. So yeah, it's like any data transfer, controlling an account from another chain, querying state from another chain, and just I think there's quite a large like possible design space and possibilities of what you want to do. It's kind of you can make quite extensive cross-chain workflows with IBC.
Right. So the way I see people compare the protocol to is like a mail service that's split into two different layers. You have the transport layer and the application layer, and then the transport layer is basically the mailman taking your post, making sure that it's got the stamp, it has the delivery address, it has the return address, and then he just delivers that. It's not really concerned with the format of the data or the shape of what the data is. It just makes sure to deliver it. If the address exists, if it doesn't exist, it just returns it back to sender, which I think is really cool, especially when people are just sending tokens without, that eliminates the risk of sending to a invalid address, doesn't it? In
Yeah.
a sense.
Yeah, so it's like I think the kind of, as you mentioned, one of the big powers of IBC is that you do have this transport application layer. Kind of these two abstractions are really well defined, and every single application that you want to develop and use with IBC is having exactly the same. We call it the packet lifecycle, the way
Right.
of sending messages from like source to destination. And then we also send back a confirmation that this message was received, and we will act on it, and it was kind of received successfully, so that the sender actually knows, okay, like what I wanted to do actually happened, which that's actually missing in a lot of interoperability solutions. Most bridges don't have that functionality. You just like
Yeah.
send and hope for the best. Um,
Yeah. Which is
but
wild.
yeah. But having this, kind of exact the packet lifecycle being the same for every single application, um, it means that the role of the relayer is quite like the relayer doesn't have a responsibility to make sure that like the information being sent in the packets is correct, because the information being sent in the packets is actually opaque to the relayer, and it's up to the
Hmm.
applications to decode the information. So this also makes it kind of like tamper proof when you're sending the packets between the chains. And it also means that relayers are just responsible for like ferrying stuff to and from. They're just responsible for the liveness of the protocol. But it also means that when you plug in like different applications, there's like some consistency in how you're actually going to move things from chain A to chain B.
Right. And yeah, consistency, right, is basically the key word here, because it's well, I mean, so many chains have these kind of makeshift bridges, right, that make it connect to each other in a way. And that was I was there when all of the hacks in 2021 were happening, like another bridge hacked, the Harmony bridge one hacked, and all these, like, one day after another, $100 million hacks were going on in crypto. It was nuts, like another day another hack. And that was, again, from my understanding, the way the bridge hacks happen is because you're basically, when you're bridging assets, you're effectively saying, okay, this token on this chain gets to this burn address. Once the other chain confirms that that token was burned, it releases it onto the other chain, but is a way to fool the first chain into thinking that it's burned or transfer that to the appropriate wallet, when in fact it was never sent, therefore just minting fresh coin on the other chain without having to confirm what actually happened on the first one. So the protocol, the IBC protocol, helps remove that kind of exploit, right?
Well, yeah, because I mean, you're with using light clients, you have to prove that something actually happened on the source or destination chain. And if you can't prove that, then you wouldn't be able to unescrow funds or mint the token to say like the sending chain actually did send the token to the destination. So yeah, I think like with a lot of the bridge hacks, there were some which were kind of like implementation bugs, and then some which were
Mm-hmm.
multi-sig exploits. So then people could,
Yeah.
literally just say mint this because I'm signing saying it happened, and it's just some random person that's taken over the bridge. So
Yeah. So supposedly it's still a bit of a learning curve for the cryptocurrency ecosystem to realize the importance of intercommunication in this aspect, right? I'm guessing because it's something that requires you to run a light client on your chain, you would need all of the blockchain themselves to kind of adopt the IBC protocol, right? Or build the chain with the protocol in mind. Would you say that it's easier to adopt the IBC protocol for a more mature-ish solution?
I think that's kind of one of the challenges we see with IBC is it's non-trivial to have a native integration if you're not a Cosmos chain, just because
Right.
there aren't really there's not loads of implementations for different blockchains out there. We do have IBCRS, which is making strides and will be enabling a few REST-based chains and rollup frameworks to connect to the network. And there is a Solidity implementation,
Mm-hmm.
which some teams have some either fork or variant of it in testnet to underpin a connection to Ethereum. Uh, but yeah, it's not a trivial task to
Yeah.
have a fully functional implementation of the protocol. And I think like the approach in Cosmos is you kind of have you have IBC enabled as a part of your kind of blockchain protocol, whereas if you look at kind of interoperability more in Ethereum and EVM chains,
Mm-hmm.
often the solutions are deployed as smart contracts. So it's kind of bridging based in the EVM, whereas we're kind of the layer below um, by just enabling it in your chain code.
Right. Yeah, that makes sense. So there's the challenge of adding new non-Cosmos chains is still there, but from what I get, is you're working to create solutions that allow for that a bit easier in a sense. Um, Does it
Yeah.
have to do at all with the code base of the solutions? I think the IBC is written in Go, if that's right, or
Yeah.
most of the packages I saw that they're written in Go. Cosmos SDK as well is also written in Go. Are you guys planning to roll out more developer support, different languages, to
Well,
kind of help with that adoption?
so we work on IBC Go, but there's a Rust implementation which
Okay.
the team at Informal work on, and there is a Solidity implementation which is kind of at the testnet stage. The IBCRS implementation is also actively being used on testnets and stuff as well. So yeah, there are a few different implementations out there, and I think as well. I mean, for us specifically, because IBC Go is the call it the reference implementation. It's
Hmm.
the first implementation of the protocol, and it's the most feature rich. It's just been developed the longest time, so it
Right.
would make sense naturally that it's the most up to date with the specification kind of thing. And we're kind of thinking about how can we make the product that we work on usable by non-Cosmos SDK chains as well.
Hmm.
So we started some exploration into how it might look to integrate with the OP stack. It's still
Okay.
very like exploratory work, really, and we will be starting work on a proof of concept in February. But if our
That sounds
approach,
exciting.
yeah, if the approach works, then it would be easier to port IBC Go to other frameworks, not just using the Cosmos SDK. But yeah, we'll just have to. It's a it's a non these are non kind of trivial challenges to try and make it more portable. So we'll see, I guess. But yeah,
Yeah,
kind of
100%.
hopeful because um, as we said, it is the biggest challenge of if you don't have something which is kind of close to plug and play, it does make it harder to use the protocol in the first place.
Oh yeah, for sure. Do you want to go maybe in a bit more detail about the solution that you're kind of planning to develop in February? No pressure if not. It's totally cool. I'm just asking.
Well, so there, I can go over in a slightly high level. So
Yeah, sure.
the idea, as I kind of mentioned, with like EVM chains or rollups, you could just deploy Solidity smart contracts to enable IBC that way. Um,
Hmm.
but in general, there's kind of issues because a lot of these EVM environments are kind of gas constrained. So, like running a
Yeah.
light client on Ethereum is really expensive. Um, so, the idea that we're going to look into a proof of concept for is so with the OP stack specifically, you have like OP Geth, which is the Ethereum client, and then you have like a sequencer, which is basically posting the transactions
Hmm.
that people are broadcasting as a sequencer through OPGraph and then posting the call data and stuff to Ethereum. But our idea is, what if you could mount like another execution engine alongside OPGath, and that would be mounting IBC Go. And then if you
Right.
create an interface between the two execution engines, they could communicate in an async way. So you could have like one execution engine responsible purely for IBC transactions, and then one which is like your EVM based engine, that kind of end user will just be doing whatever stuff they're doing on that rollup. So yeah, the proof of concept is examining whether we could actually create like mount two different execution engines in parallel. So yeah, we'll I guess we'll we'll see. I think it's a cool idea, and there's already some work going on by other teams to try and have like a OP stack integration, specifically Polymer, who are taking
Yeah.
like a different a slightly different approach because they're just mounting the Cosmos SDK onto the OP node. So yeah, we're kind of all collaborating, working together on sharing ideas and solutions. But yeah, that's
Right.
kind of the thing that we're going to try out. But yeah.
That sounds super exciting, though. It is obviously such a. I hope it works. It sounds like an incredible solution to a real problem, and I think that's also where community becomes like really really important, right? Because all of these tools are open sourced, right? So people could communities could try and find a way to find a solution to that problem. They could just run it, a mock chain locally and figure out a way of doing it, which is, it's fantastic that it allows for people to kind of come up with solutions if they want to, if they're keen to contribute to that.
Yeah. I mean, I think it's, yeah, the blockchain space is just like evolving really rapidly. And,
Yeah.
it's like the way it was 2 years ago is already quite different to how it is today. And yeah, I think the technology is just, the pace of change is quite quick. So yeah, people will just keep innovating.
What do you guys what do you guys think lies ahead in terms of well, from interoperability to scalability to security? uh, what do you think is on the horizon in the next few years?
I haven't. I can answer.
Go ahead,
Yeah.
Susan.
I think like zero knowledge proof based technology is going to be really important. For interoperability, you've got kind of the use case of like compressing the proof size, so being able to update a light client in a cheaper way.
Right.
I really believe in the kind of privacy use cases as well, because yeah, I think that there's some clearly it's good to have this kind of verifiability and the immutability of blockchains, but I think if blockchain technology is going to underpin like the new financial system, you just couldn't really do it without privacy. Um,
Yeah.
so yeah, I really think that's going to be important. So yeah, and I think it seems like there's more teams working on ZK based stuff,
Hmm.
and I think the technology just seems to be developing. I'm definitely like far from being an expert on the subject, but
Oh, neither am
yeah,
I,
it
so don't
seems
worry about
like
it.
it's moving into more people actually having like tangible applications or like privacy chains. Well, there already are some privacy chains like Zcash and stuff, but new
Yeah.
privacy chains and new designs are emerging, and they will be launching in
Yeah.
the coming years, kind of thing. ZK
I was
roller
actually talking to
stuff.
someone
So.
with they're rolling out a privacy chain solution. I forget the name, but I'll definitely send you a name. I think it's really interesting. So there's a distinction, right, between privacy from like end to end, as in hiding the user or the wallet, or hiding the contents that are being transferred through. So from the discussions that I've kind of had recently, it seems like a move towards um, protecting the actual transaction details. So you're not going to know if I sent you a certain NFT or a certain amount of tokens or something. You can see the wallets interacting with each other, but you won't be able to see what they're actually transacting. Uh, which makes things a lot safer and a lot less prone to exploits, because you're I think that's important.
Yeah, I think it's like on Ethereum, it's like MEV is a big problem.
Oh
Again, not
yeah.
an MEV expert, but I think if having private mempools, or if you just had private transactions as a default, or you use things like threshold decryption, where the transaction is only revealed after consensus has been reached on a given block. Things like that will just already massively reduce, that like loss from MEV. So and then it's like, people would have more kind of ownership over their specific trading strategies or something, and they're not going to get sandwiched or whatever, things like this.
Yeah, take away the MEV bots from the decks, and suddenly no one's making money in DeFi anymore.
Yeah, maybe it's like
You
detrimental consequences then.
yeah, you can't front run anybody. This is no fun. But yeah, no, that's a super important thing to be solving, and I've seen a couple of projects looking to solve this kind of stuff. I've also seen a move from like being an AMM or like being a liquidity provider to being more of a trader in DeFi. It just gives you more of the yeah, it just allows you to do more stuff with your crypto and more take more control of decision making rather than just providing liquidity hoping that the pool will remain profitable.
Yeah, yeah.
But yeah, so in terms of interchains future in crypto and the crypto industry, um, what are you guys aiming for in the next few years? What is like the ideal vision for you guys?
I think on a very high level, one thing that was very fun to see in the last 1 or 2 years, I would say, was these, like the thesis of Cosmos, the interchain of blockchains, was like really verified. We have saying all this, we have all these hundred of blockchains, and
Yeah,
they are trying to communicate to each other. At the beginning, Bitcoin and Ethereum, they used to think of we are going to create everything on like this blockchain, and there is not that need to talk to each other. That thesis Cosmos came and was like, yeah, no, these blockchains, huge blockchains, are not going to be just an island, not and everything is going to be built in one thing. um, that thesis was validated. Cosmos had that vision since like back in 2016, 2017,
right,
when yeah, things were like getting some traction. So now what we need, and what we really need to focus on is adoption. And for that, we really need to try to extract somehow all the amazing technology that enables all this functionality for blockchains and enable a lot of use cases. But we are still very far from the mass. From like your normal people. And
right.
of course, we have to start somewhere, and like you have to have that initial target market. And they are, for us, they are developers, and they are like when very savvy on the technology. But maybe not not necessarily for us as a foundation, who we are funding all this amazing technology, or this interchain stack, and IBC, and the SDK, and Command BFT. But maybe we need to start like also trying to push for the builders to also pay more attention for adoption, and like make it easier for people to use
Right.
the tools they are building. And so yeah, that's one of the important things to tackle, because that will bring adoption. um, and that will bring adoption, like if people are starting to use all these blockchains and all these tools out there, then we're going to have more builders, which are the developers that are going to be using the stack to set up their blockchain, and like, yeah, provide a solution for their use cases. So I think that's another thing that we need to tackle.
Yeah, and actually, I was just talking to the co-founder of Horizon in my last episode. They're building a platform that helps game developers connect to the Web3 layer, and then connect to using SDKs. They can connect to like Unity or other game engines and pull like chain data from the chain to use it in their games. And I feel like the conclusion is tends to be similar across different spaces, that you gotta first take care of the developers. You gotta have to give them the tools to build the products that then the people want to use, because it's a new technology, because it's still emerging, because there's still a lot of unknowns. Even
Hmm.
people that are specialists in the industry still have a lot of unknowns and problems to solve. Building for developers effectively means building for the community later down the line. So I think in many ways it's
Hmm.
just building for the future, isn't it?
Hmm. Hmm. Yeah, exactly. And of course, we need to focus, right? And like our focus in the case of the Interchain Foundation is the builders and the savvy people. Make sure that they have the right tools in order to go and create their blockchains. And they are the ones that are more concerned with talking to the end user. Um, However, I think sometimes we have to, like the fact that we are focused on something, necessarily that doesn't mean that we need to forget about the other side. And
Right.
even if I don't see that that's one of our priorities, we need to start talking also with those developers to see yeah, how they see adoption. What are the type of use cases that maybe we need to prioritize, for example, and make sure that those developers in that set are like served, and so they have more time to really think about, instead of like solving big tech problems,
Yeah.
they like find the time to really make sure that they can reach the end user, and people can use the people don't need to learn that much about the technical side of things in order to be able to use this thing. And we are not there. Even for us, sometimes things are tricky and
Yeah.
like difficult to use, and like we are scared of sending a transaction. So it's like uh, we start need to think about that if we really need adoption, if we really want adoption.
Yeah, no, 100%. And that just makes so much sense. Just thinking about if it's still a challenge for people in the space to use some of the technologies, then, people that are non-technical, how are they going to go and, navigate the space? Like, I don't think it's that kind of common knowledge, like, hey, this is how email works, or this is how, it's not there yet, and it's probably not going to be there for a while. And especially with a solution like interchain connection, or things like Cosmos, or solutions like Polkadot, this is like really building way into the future. It's an amazing
Hmm.
vision that still needs to cement itself. um, but I think some of the use cases are effectively creating immutable data for, I mean, any kind of organization, right? You could be a hospital, right? You could be a hospital wanting to host data on chain, and then have a way of communicating with all the other hospitals that all have their own little network that are
Hmm.
connected by an interchain solution, right? Or something like that.
Exactly. Yes.
But I think for things like that, it's like you would inevitably need privacy, right? Because like GDPR is already such a massive, especially in the EU, is
Oh
obviously a
yeah.
problem. It's like if you're putting uh, hospital data on a blockchain, you need to be able to verify that it's going to be private. I doubt you're going to be putting that stuff on like a public blockchain,
No,
obviously.
you probably wouldn't want to do that.
Yeah.
No.
Um,
No.
but yeah, I think it does seem like a lot of those kind of other use case, like supply chains, or um, there's some of like real world use cases, like some internet service providing, like blockchains actually creating a real life network. There's the environmental kind of carbon credits tracking stuff. Yeah, I think it's like people have some kind of signal amplification thing, but then they also have like a node, so it can keep track of like who connects to your like signal provider. I don't know precisely how it works, but I remember talking to someone who told me about it, and they were saying that a problem with like internet in maybe some like less like developed countries is that people are kind of overcharged because they
Right.
kind of put the like they have discrete like blocks of usage rather than actually paying for like how much you actually use. So like the blockchain kind of solves that problem because you can directly track like how much data did someone actually use when they connected to this node.
Right. But do you think is that kind of the best way of providing that service, or would it just be like a flat fee like we most pay for our broadband? Hey, here's the flat fee. I can just watch Netflix all day long if I want.
Yeah, I guess it. I mean, that's like a question about like pricing models generally, right? Should it be pay for what you use, or do you just have the unlimited amount? I guess it's like for like we're in a privileged position where paying like 50 euros or whatever a month is not a big
Right.
deal, whereas that's probably not the case. You know, and internet access is actually still not like the norm. I think there's something like 1 billion people who don't even have access to the internet in the world.
Yeah.
And
Yeah.
yeah, there's still lots of kind of development, you know, to have actually full coverage in the world.
Yeah. Solutions like Starlink could totally help a lot with that. If there was more volume for solutions like Starlink, it's just basically internet via satellite.
Yeah.
Apparently, it doesn't work well at all in the city because there's just too much noise in terms of like wavelengths and frequencies. But in less populated areas, that is very useful. So that could be a solution. Could that be delivered kind of like via a blockchain thing, pay as you go, something potentially, I guess. Yeah.
Yeah, no, I don't know. I mean, I don't even know in detail how that application works. I just remember talking to someone and thinking, oh, it's like an interesting real world application of blockchain. Um,
Yeah.
rather
There's a
than, you
few,
know,
I think. There's a few blockchain organizations trying to solve the internet problem, the issues in Africa. I think some of them are trying to do it with like kind of like those meteor balloons that you put up in the sky and then kind of. I think is very similar to what you're saying, Susanna. I think they're sort of allowing connections based on the amount of usage as a price, and you're like running a node effectively kind of pays in a sense for that usage in a way, and it makes it inherently fair because you never pay more than you use and there's literally no markup. And I think that's where the issue is, like we pay whatever it is, 50-60 dollars a month for internet, but there's a huge markup if you actually consider the network cost, which is probably minimal.
yeah,
Yeah.
yeah, yeah. I mean, the yeah, I've always the internet in Germany is not very good, but
Oh really? I wouldn't have thought. I thought
no,
I thought it'd be one of the best.
no, no. I think countries like South Korea and Japan are meant to have like some of the best internet connections in the world,
Yeah,
but
I think is Japan.
yeah.
Do you guys have any announcements that you want to make? Anything in the future for people to look forward to? Any particular links or anything that you want people to get involved in at all?
Well, I can give a brief shout out to our latest release, which will be by the end of the month. Um, so our latest release will be v8.1, and the feature that it's got in this release is called channel upgradability, and this is a
Hmm.
way to basically upgrade an existing channel with IBC. And this is really cool because if we think about like technology generally, it's like something that was made 2-3 years ago. It already kind of becomes outdated as soon as you like, you know, it's like the computer you buy as soon as you buy it. there's already it's already depreciated in value because it's no longer new, and that's just kind of true for all technology in the world.
Yeah.
And so channel upgradability allows you to upgrade the existing functionality of a channel. So a channel is just you can think of it as like the path that like data packets are moved from one chain to another along. And this means that you can extend kind of the existing applications that you're using this channel for to send packets between. So for example, if I'm using a channel to send tokens between two chains, I could now upgrade this channel. So I could add middleware on both sides of the channel. So this would basically then enable you to do things like incentivize relays along this channel, or
Right.
you could change like the ordering of the channel. So you might have a channel which says I have to deliver packets in order, so sequentially. And then you might say, okay, actually, I don't need this anymore. I want to change it to be unordered, so packets can be delivered like in any order rather than having
Right.
to be time based from when they were created. Or you can just say like you wanted to extend and change an existing application. Now you can do that without losing like all of the state you built up from moving like packets along this channel. And this is like really important for tokens because fungibility is just kind of probably the most important thing when you think about interoperability.
Mm-hmm.
But so yeah, it's just a way that like enables us to kind of keep pace with changes of technology, improve the protocol based on changing user needs, but do this in a way which isn't going to sacrifice kind of all of the fungibility of the tokens that you sent along this channel in the past, or just all of the state that you accumulated on this channel.
Right.
So yeah,
So
maybe,
it's all backwards compatible still,
yeah.
basically.
Well, the upgrade is not backwards compatible, but it's like you don't have to create a new channel. It's like you can retain
Right.
the channel of communication, but now you can extend its functionality.
Right. And you've mentioned that you can deliver data packets in sequential order or in any order. What would be the advantages of either, and why might you want to do one or the other?
Um, so if you had an application where the order of the delivery of the packets was really important, like you wanted to perform actions, but they had to perform in a certain sequence, then you might want an ordered channel. But for token transfers, you don't have an ordered channel. Another kind of,
That makes sense.
well, maybe this is more of like a future idea, but you could also use channel ordering to prevent like censorship. So if you had some um, connection between the packets that are being created in this channel, and to say, okay, after like so many packets have been delivered, I have to make sure that I've delivered packets from like 100 packets earlier. This is kind of a way to prevent people from just censoring and never actually sending certain packets. So there's kind of some ideas and areas to explore if censorship resistance is something that people really want. That's also a possibility with changing the ordering of channels.
That's cool. I like that.
Yeah.
Well, thanks a lot, guys. This has been a fantastic
And
conversation.
yeah, and if
Uh,
people want to learn more about the interchain stack, they can go to interchain.io. They will find all the links
Interchain.io
to.
to find
Yes,
out more about the interchain stack. Awesome.
yes,
And that's
exactly.
where you're also going to have all the open source repos, right? Like the interchain, the IBC repo and the Cosmos SDK repo, and everything like that. I did have one more question around the language. Is there a particular reason for choosing Go uh, to write some of the packages?
I
Susanna, this
I
is for
mean,
you.
that decision was made way before I was ever involved with the Cosmos ecosystem. But I think it's probably picked because it's a relatively easy language to onboard to, but has like secure properties. I think generally, like it seems to be a language that people are using not just within Cosmos, but in the blockchain space generally. I think because there's a general like security consideration when you're developing anything in blockchain. So it kind of
Right.
fits the bill for being like sorry, my headphones disconnected. I don't know why. For being secure, relatively easy to onboard to, good for distributed systems. I guess that's just why it was chosen. But I honestly have no idea. I was not involved.
No, that's fair. I was just wondering because sometimes you do have choices like, oh, Polkadot does Rust, and there was another project that did Viper, which is like another like a Python-like language, which just turned out to have a lot of security issues at some point, which were also they caused one of the hacks we had earlier last year. So I was wondering, but yeah, that's all good. Was there anything else, Maria, that you wanted to add?
No, nothing else.
Okay, well, perfect. Thank you so much for the conversation, guys. This has been a great pleasure to sit down with you and kind of talk about interchain, future of blockchains, and everything in between. And I wish you both a very nice day.
Thank you,
Thank you.
Andrew. It
Thanks.
was very
Bye,
nice to
everyone.
meet you. Bye
Bye.
bye.
Nice meeting you too.